Okay guys, you asked for it. A video about tensions and gauges and madness. I'm going to try and get through this as quick as possible, hopefully under 10 minutes. If you want a proper explanation and someone who's actually talking about it properly as a physics expert or a more professional video, then by all means there's loads of videos on YouTube that can explain it much better than I can in much more detail and much more professionally. I'm just going to try and whip through it as quick as I can to explain what we're doing in terms of this Bechstein restoration. So I said in the previous video that we're trying to keep an even tension. Whether you want to argue for different things, let's just keep it as simple as we can. This is, piano restringing for beginners. So, for the sake of averages, let's say a tension of 75 kilos per note for every single note on the piano is a good desirable figure. Some people prefer higher tension, some people prefer lower, but let's say 75 kilograms of tension is what we're aiming for. So how do we calculate the tension? I hear you all cry simultaneously. Well, for our purposes, and physics teachers are going to be screaming at me for this, but for our purposes as piano technicians, tension is dependent on three changeable factors: the frequency, the length, and the diameter. So if we imagine a piece of music wire vibrating at 440 hertz, you've got a piece of wire stretched over the thing, concerté on a piano. Now in fact, let's do this with examples. I've not planned this, I'm just going to do it. There we go. Thanks, Grace's mum. Right, if you've got a piece of wire stretched over from one point to another, like that, let's say that's vibrating at 440 hertz, which is the pitch of the note. If the frequency was increased to 442 by pulling the wire tighter, which I do a little dot here, wrong way. See, the length has remained the same. The length of the speaking length of that string is still the same. The diameter of that wire is the same, but the tension has increased because I've pulled it tighter. I've actually used this to pull the string tighter. So the pitch has gone up. Now, if the length was decreased, oh, sorry, yeah, that's it, done it. If I decrease the length of that, that's also made the pitch higher because I've shortened the amount of mass of the wire. Or I can pull it back and it goes lower. The tension has not changed. I've not changed the tension on that note, I've just changed the length, and the pitch has changed. So, now imagine if we covered that wire or replaced that wire with a thicker string and kept that tension the same. All we've done, or you could say, if we wound a copper covering over to there, we've changed the mass of the string, we've made it heavier. That string, even if you didn't change the tension, would be lower in pitch. So the things we're looking out for on that is the frequency, the length, and the diameter all affect the tension of the string. All the tension and the length and the diameter affect the frequency, etc., etc., etc. So we know there's three factors which affect our tension, which we're trying to get even. Remember, all the tension is supposed to be even throughout the piano at 75 kilograms of tension. We've got as three factors: frequency, length, and diameter. So let me write the calculation out. In fact, yeah, I'll just show you my sheet. I've printed out these notes as well. I've given them to my class at Newark because I teach piano tuning at Newark piano tuning course, and these are my notes that I use for the students. Now, that there is the formula. Can you see that? Frequency times length times diameter squared times pi times 7.85 divided by 10 to the power of 9 equals newtons in tension. Now, if you want to change that to tension to kilograms, you've actually got to do the newtons divided by 9.80665. Simples! Simples! Yeah. Right, well, that's all there is to it. You know, there we go, video's done. Now, so basically, how can we use this formula to find out what we need for recalculating the string tensions? Okay, it's basically, let me put them back up there so I've got them out of the way. It's basically a fill in the blanks idea. Let's have an example. If let's say we're looking at note A440 on a piano. We measure the speaking length, the length that wire is supposed to be, and find out it's 393 millimeters long. And so we know the frequency we're trying to aim for. The frequency we want is 440 hertz. We know that the length of that string is 393. We know that the tension we're trying to achieve is 75. So all we don't know is the diameter, because the frequency can't change because we want a specific frequency for that note. We can't change the length of a piano speaking length because that's set from the piano. So the only thing we can do to get the desired tension that we want is to change the diameter of the wire. So let's guess randomly. Let's say we want a diameter of wire on that string that's 0.925. So running that through that incredibly complicated formula down there, what we do is we say 440 hertz times 393, which is the speaking length, times 0.925, which is the diameter of the wire, square all that, times it by 3.141592653589793238462, something like that, which is pi, times that by 7.85, which is the actual, is it the density of the wire or the mass of the wire? Is a proper word for it. I think it's the density. Anyway, that's a set weight of the wire. Divide all that by 10 to the power of 9, is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9. If you run all those figures through your own calculators, you should come out with a tension in newtons of 630, which then, if you calculate it into tension of kilograms, comes out at about 64.3, which is too low. So that tells us we guessed at 0.925 for the diameter of the wire, but the tension's too low. We want it to be about 75, it's 64. So we increase the tension. Yeah, we need to increase the tension. How do we do this? We can't increase the frequency to get the right tension, because if we increase the frequency, that note's not going to be A440 anymore, it's going to be A450. Can't do that. The note will be sharp to concert pitch. We can't increase the length of the string, not without recarving the bridge, at least. I mean, that's a bit extreme. We can change the diameter, so let's put a different diameter on. Let's put gauge 17 on instead, which is about 0.975 instead of 0.925 that we used before. Run all those figures through the calculation again, and you should find that it comes out somewhere about 700 newtons, which calculates about 71 kilograms of tension. I know this because I've done the calculations already before this video, just so that I've got some examples to show you. After trial and error, we go, that's a bit too thin. So after trial and error, we find the closest wire gauge is 17.5, which gives us a tension of 75.19 kilograms of tension. This is as close as we can get to 75. We have therefore found the best gauge piano wire for A440 on that particular piano. Not on every piano, just on that piano. And then you've got to repeat it for every single note on the piano. Yay! Now, that might sound confusing as hell. And what makes it worse is that there's other things to consider as well, like which notes are returns, which notes are eyes. If you've got returns, you can only change gauge of wire every 2 notes rather than every single note because of how they loop round at the end. There's a lot of other things to think about, but basically I normally start at note 88 and work down because I know 88 is roughly going to be about 13.5, 13 gauge. So as a good rule of thumb, I start out at 13, see if I can find the tension and work down from there. I don't do the calculation, actually, every time. I've got it set up for a spreadsheet, and then the spreadsheet does it for me. And the spreadsheet is on Phil's PC, which was what I was going to show you, but I can't. So, because the thingy is not working properly. So there we go, I've put all my notes back up again, and we'll leave it at that, because it's 10 minutes long, this video, which is about average for my videos. I mean, like I was saying, it's very uncommon to actually run through the formula by hand using a calculator. Unheard of these days to do it by pen and paper, but that's how everybody was doing it back in the 1900s, you know, so before calculators they had to do it like this. And then you expect the gauges of wire on a piano that hasn't been restrung for the past 120 years to actually be the right gauges when they were all doing it by pen and paper, and they're coming out with figures as massive as billions. You know, it's hard work. But technicians these days have the opportunity of taking advantage of the life-saving miracle known as spreadsheets. So if you create one in Microsoft Excel like we've done, you can do that. The formula I have used today is not actually the simplest way of working out the tension, and it's not the most sophisticated. I've just chosen this way because it demonstrates what we're trying to achieve rather than the most productive way of getting the end result. More sophisticated formula and spreadsheets used by technicians in the trade also incorporate other aspects of stringing. For example, the stiffness variable of the wire, because how stiff it is when it's pulled to a certain tension, the inharmonicity allowance, and the alternative wire densities as well, which is a lot of other stuff to consider as well. And neither is the calculation for bass strings, which is where we work out the copper covering for each individual note. But this is meant to be just to explain what I'm doing on the Bechstein's rebuild project. This is not a how to do this, you know. Please, for the love of God, don't try restringing your piano if you're just watching these videos and you don't know about piano tuning or restoration yourself. Please don't, because you're just going to wreck your piano. In fact, that goes for everything that I've been showing you thus far on these videos. Don't think these are a how-to. These are a step-by-step what we're doing for this piano. I have seen people go before. I've been out to so many pianos when I'm going out tuning, and people have said, oh, we watched a video on YouTube, so we tried to do it ourselves. And the piano now doesn't work. Can you tell us where we went wrong? So no. Basically, I'm just showing you what we're doing and what's involved with piano restoration in these videos, and this isn't the only way of doing it. You can do it lots of different ways, lots of different... you can restore pianos in many different ways, and this is just what we're doing on this particular piano. Another piano will come in next time after this Bechstein, and we'll rebuild it in an entirely different way, because that's what works best for that piano or us at the time, or we've improved on things we've done in the past. Right. I'm going to pack up this video now and get it uploaded, because it's now 14 minutes long, and if I go over 15, YouTube's going to send me another reminder saying you can't upload videos longer than 15 without verifying your account. Verify my account?